Hello everyone, today I am going to explain the sixth problem of AtCoder beginner contest 281, which is XOR minimization. What is the problem? So we are given an array A of n integers, which is A1 to AN, and we have to choose some integers x, and we have to transform the array x to transform the array A to something like A1 XOR x, A2 XOR x, like AN XOR x. This XOR is nothing but the bitwise XOR operation that is clearly mentioned in the problem statement. So now we have to, what is the desired answer? The desired answer is nothing but uh, we have to pick the maximum value of A after the operation, and we have to minimize the value. So let's say we have chosen some x, and we will get the maximum value from this modified array. Let's say this as maxi. Now for all the x's we have to minimize this maximum. This is nothing but the problem statement is quite simple. Now let's jump into some observation. So the first observation, let's write it observation 1. So for that, let's consider some elements in bitwise format. So let's say this is 1010, this is 0010, and this is 000. So let's consider it as 0111. Okay, so let's say we have three elements. So now we have to choose x. So let's say there are other zeros here, 000000000. So now this is more I think you all might observe that there is no point in taking let's say we are now constructing x. So let's say we are not now constructing x, so there is no point of taking 1 in either of these bits, because if we XOR with any of them it will give us 1, because 0 or 1 is 1. So we will obviously take 0 here. Okay, we will obviously take 0 here. I hope you got it. So now we have to come into the MSB of any of the integers, okay, given to us. So let's say we are at maximum of, we'll take maximum of a and just consider MSB of this. So this will give us this, the third bit. So this is 0th bit in base indexing, 0 1 2 and 3. So now let's observe one thing now. So the thing to observe is here is that if we take 1, if we take 1 in the third bit, then 0s or 1 will give us 1 and 0s or 1 will give us 1. So either from these two, either from these two we will give our maximum answer if we take 1 here. Now if we take 0 here, if we take 0 here, then we will only get maximum answer from this element. Okay, because zeros or 0 will be 0, so this bit is not set in the answer. And if we consider this element a1 or x, it will be set, this bit, third bit, will be set in the a1 or x, but not in a2 or x or a3 or x. So our answer will be a1 or x if we consider 0 in this third bit. If we consider 1 in the third bit, it could be either a1 or x, a2 or x or a3 or x. So you might observe is that we are just partitioning it into two sets. So let's consider we are at let's say we are at some bit j, we are at some bit j, and we have an array or we can say we have an set s, we have an set s, and we are at j bit. So now we will partition it into two sets. First set is s1 and the second set is s2. So s1 will contain all the elements such that j bit is set, j bit is set from s, okay, obviously from it. And here nothing but j bit is not set. Okay, so there are two elements. So it could either happen in this case or this case or this case. The s1 is empty. Okay, s1 is empty, so we are just considering the entire thing into s2. Okay, so I hope you got it. Now this is the observation 1, and the second observation I want to make, the second observation that we have to make is that if either s1 or s2, if both of them are not empty, if s1 is not null and s2 is also not null, then this bit, our current jth bit, should be 1. Sorry, so or in the resultant our jth bit is set. If s1 is not null and s2 is not null, in the resultant the jth bit is set, because if we take 1 here, from a1 we will get the resultant which has jth bit set. and if we take sorry, if we take 1 here, then we can we'll get answer from this A2 or A3, and if we take 0, we'll get answer from A1 as the jth bit set. I hope you got it. So that is the case. If so that is the case if both are not empty, then the resultant will have z bit set, and if one of them is empty, then we'll have the resultant bit as not set. Okay, so now, so what is we have some, so what is will be the time complexity. So we are iterating over bit 30, and we are iterating over the set, and every element will be present in the what like every element will be present in one of the sets, so it will be order of 30 into n. Okay, so you can do it in the set way itself, but there could be some problems. There could be some problems where we want to separate the first set and the second set. I don't know how we can do it, but instead of that, what I have done, I have used try. So let me explain my try approach here. You can find other solutions also not involving try. You may look into it, but the entire the core observation will be the same. We are just separating it into two sets, s1 and s2. If s1 and s2 are both not empty, then the j bit will be set, and if either of them will be empty, then the j bit will not be set. Okay, and we are just this is nothing but recurrence, so we are just we are at recurrence of j comma s. We'll just do two, like there will be two transitions. One will be from j minus 1 is, so let me write it. Mm. So if we are at something like let's delete this first. So let's delete this. So let's say we are at something like recurrence of j comma s. So we'll just do recurrence on j minus 1 is one, and recurrence of j minus 1 is 2. Okay, I hope you got it. So now let's jump into the try solution, what I have done. Okay, let's jump into the try solution with this. Now what is try? I hope all of you know what is a try. So we have some root here, and here we can take from two paths, root 0 or 1. So here I am considering try nodes, as the try node will contain the counter and the pointer to the next node. So here it will be 0 count, and here also 0 or 1. There will be two pointers. First pointer will be of 0 and the second pointer will be of 1. Similarly 0 and 1. So this count will contain the entire, like this count will contain the number of elements in the current try node. Okay, so let's say I hope you know how to insert an element into a try. I will not go deep into how to insert an element into try, but when we are just inserting one element into try, we'll just come from here and here. We'll just increment the value of counter. Then again, let's say from 0, we are just coming here. We'll just increment the value of this counter. Now let's say we jump from here to here. Let's say there is another node here, and we'll just increment the value of counter here also. Okay, so each counter will contain the number of elements in the set. So let's consider according to our problem, let's consider this counter as this s. The count of element is s. Now here this will be s1, because the according to our definition, this will be s1 because the j bit is set, and s2 where j bit is not set. So now if we are doing some kind of depth first search in the try, and we are at j comma node, some node in the try, j comma node, we'll just do if we just go to the this pointer, we'll go to this pointer. Let's call it node 1. Node 1 is nothing but j minus 1 comma s1, sorry, s2. And if we go to this node 2, node 2 is nothing but j minus 1 comma s1. I hope you got it. Let's jump more deeper into the solution now. So as I explained that we are just iterating on j comma node. We are just iterating on j comma node. Now we will just check. We will also have the count. We will also have the count. Now we will find this is node will, let's say node, this is a try node, and there are two links here. First one is node 1 and the second one is node 2. Okay, so we will just find this is the count, the number of elements in this set. So this will be count 1 for node 1 and count 2 for node 2. Now if we will check, as I have previously explained, if we will check count 1 is equals to 0 or count 2 is equals to 0, then we will not include 2 to the power j. Okay, we will not include 2 to the power j. Okay, and if the either of them sorry, both of them are not 0, then we'll include 2 to the power j. So I think you will not understand if I will not show the code. Let me show you the code now. So here, this is trivial insertion. I am using try as a tree, sorry, try as an 2D array. uh, I will try to give some link of this blog, Code Forces blog, where I have found this try with 2D array. You may go into that. So now here just comes the DFS part. The first one is node. Node is, if you use pointer based try, yeah, this node will nothing be but try node. And here C is count, and the number of elements in the current node, and J is the bit, I have already told. So if J is less than 0, J is less than 0 is that we have covered all the bits, we'll just return 0. Now if the count is 0, we'll just return infinity, because there is no point in taking this path. Because let's say let's come here. So let's say we are at this node and the count 2 is 0, so we should not go in this path. So we'll just return infinity from here, just that this iteration is stopped. So returning infinity means that we are just stopping the iteration here, sorry, stopping the recursion here. So so where we are just stopping this iteration. Now c0 is nothing but the number of elements in the current is sorry, number of elements in s2, and c1 is the number of elements in s1 according to our definition. Now we'll just answer is minimum of DFS try node 0. So we're just coming to node 1, and this is count 1 and j minus 1, and this is nothing but node 2, count 2 and j minus 1. And here we are considering if s1, if both of them are not null. If s1 is not null, so and s2 is not null, we are just doing answer plus equals to 2 to the power j. I hope you got it. I have already explained if none of the sets, both of the sets are not empty, we just if we take if we set the bit in x, or if we not set the bit in x, we will just have the resultant bit set in the answer. So we just return answer here from here. So here this is quite trivial. We are just taking in inputs, and we are just inserting it into the x, and at the end we are just doing DFS. So our first node will be obviously be 0, and the number of elements in the first node will be n, and the bit here 2 to the power 30 is mentioned, so I am considering from the 30th bit. This video is quite long. I will try to give the link of the try implementation or the CF vlog, where we can implement try using 2D array. You can go through it, or you can search it into YouTube or Google also. Uh, if you still have any doubt in any part of the video, you can always ask in the comment section. I will try to reply each and every comment. Please like the video and subscribe to my channel. Thank you.